Let's solve this definite integral from 0 to half pi, log of sine x dx. First, I can let x equal to half pi minus theta. Right. Dx becomes negative d theta. Also change the boundaries. So the integral now is just when x is equal to 0, theta is equal to what? Theta must be equal to half pi. When x is equal to half pi, so theta must be equal to 0. Right, there is a negative d theta, so negative. Right. Log sine x. Log sine half pi minus theta. D theta. So negative, get rid of negative sign, switch the boundaries. 0 to half pi. Log sine becomes cosine. Trig identity, cosine of theta. D theta. Now, turns out that it doesn't matter if we have sine or cosine. Right, the rest is the same. Same integral. Right? All we have to do is work out this one. So, then I can somehow use the double angle formula. Right, so, I can turn cosine theta into cosine square half theta minus sine square half theta. Right, this is the double angle formula for cosine. Now, somehow this is a difference of perfect square. Cosine plus sine times cosine minus sine. Right? We have a product inside log, so we break the log apart into a sum of log. Right? So this time 0 to half pi log cosine plus sine plus log cosine minus sine d theta. Right? Now, this can be written into 0 to half pi log 2 over square root of 2 times square root of 2 over 2 times cosine plus half of square root of 2 times sine. Likewise, this is log 2 over square root of 2 times half of square root of 2 times cosine minus half of square root of 2 times sine d theta. This is because this is its reciprocal. This times that still 1. This times that still 1. Likewise, this. So it's the same thing. So square root of 2 over 2 is cosine of pi over 4. This is cosine pi over 4. This is cosine pi over 4. This is sine pi over 4. So this is just 0 to half pi log 2 over square root of just square root of 2 times so cosine pi over sine pi over 4. Right? This is cosine pi over 4. So sine cosine plus cosine sine is the angle sum of sine. Right? Angle sum of sine. Sine half theta plus pi over 4. Right, 45 degrees. So sine 45 degrees equal to this, right? Cosine 45 equal to that. So this is this bit plus that bit, square root of 2. So cosine pi over 4, this bit this sine pi over 4, this bit. Cosine, cosine minus sine, sine. So cosine angle sine. Cosine angle sine. Half theta plus pi over 4 d theta. Okay. And then we just log, we have a product inside log. So we break it apart, right? Sum. Log square root of 2. There is a log of square root of 2 as well. So twice of log square root of 2. But put the 2 on this power. Square root of 2 to the power of 2. Just 2. All right, so this is good. And now I have log sine is the same angle. Log of cosine, same angle. I do this integral. But this integral is easy, right? It's easy because this is already a constant. So this is easily just half pi times log 2, right? This integral, okay, I'm going to steal 0 to half pi d theta plus log 0 to half pi. This theta, I change this theta into u. Same thing. It's the same thing, same integrand, right? Doesn't matter. So eventually I have this, right? This integral equal to this integral equal to this whole integral, right? So this is a constant. Somehow if I can turn those two integrals into the same form as this integral, then we can, using this constant, solve for the integral. Okay, to solve our desired integral, I've just turned it into a similar integral, right? Except we have cosine inside here. So a constant plus two integrals. So for example, this integral, theta, right? I want to change sine into cosine. So what do? So I just write half of theta plus pi over 4 equal to half pi minus alpha, for example. So therefore, for this one, I have alpha is equal to what? Pi over 4 minus half theta. And also, d theta is equal to what? Times 2 on both sides. Theta equals to some constant. Right hand side, I have negative 2 alpha. So others don't matter. Just negative 2 d alpha. Right? That's all that matters. So also for this part, u, right? I let half u plus pi over 4 equal to beta. Right? So that du times 2 on both sides. Looks like it's 2 d beta. Right? Following this, we can change the boundaries. Right? So pi over 2 log 2 plus the new boundaries would be, like I said. So when theta is equal to 0, alpha is equal to pi over 4. When theta is equal to half pi over 2, pi over 4 minus pi over 0. Right? So log sine angle becomes this angle. Sine this angle is equal to cosine of that angle. Right? Cosine alpha. d theta becomes negative 2 d alpha. Negative 2. Okay. So this new boundary, when u is equal to 0, beta is equal to pi over 4 as well. When u is equal to half pi over 4, pi over 4 plus pi over 4, half pi, still half pi, log cosine beta, cosine new angle, right? Du becomes 2 d beta, 2. Right? So here we have exactly the same integrand, log cosine, right? Except we have alpha, beta. But as we all know, the variable doesn't matter, right? The integrand is the same. It's just the dummy variable. Right? Still integrating over this different boundaries, but still integrating under the same curve, right? Same function, same integrand. So I can easily change beta into alpha consistently, right? This is perfectly safe, right? Perfectly legal. So we have different boundaries, but same integrand. We can, of course, combine them together. Right? This is allowed. Except we have maybe take out the constant. Right? Take out the constant here. Here, integral from this to half pi. There we have a minus sign, right? Integral from this to that. Half 0 to 4. Perhaps I can change the boundaries and change the sign. I can say plus, change the boundaries, 0 to pi over 4. Right? This is perfectly legal. Right? Plus 0 to pi over 4. So you see, the integrand are just the integrand is the same, right? Same integrand, just different boundaries. But the 0 to pi over 4 to half pi, right? Same integrand. What's its graph? Right? I don't know the graph. Some random graph, right? Some random graph. But the idea is that when you plus those two integrals together, what do? You just the integral from the area under the curve from for this segment plus the area under the curve of this segment. You say the area under the curve of this segment, 0 to half pi, of course, right? Of this integrand. Cosine alpha, but then I can change alpha consistently into theta, right? This is perfectly legal. So, in fact, we have what? I is equal to this integral, right? This I equal to this plus twice of, what is this? Looks familiar. This is this, right? The desired integral. We'll get times 2. So, all in all, I is equal to that, some constant, I don't know, some constant, plus 2 times I. So I move to this side, move this to the other side. Right, this I comes to this side, 2I becomes I. This to the other, so negative half pi times log 2.